Hello, everybody. This is Tobias, and today we are going to talk about hydrological modeling. We are specifically going to talk about how to think about the hydrological basin in an abstract way, in a conceptual way. So the question we want to look at together today is how can we understand the reality in a way that it can be translated into a hydrological model easily. And so I want to show you thinkings and some steps in this regard, and I hope that I make myself understandable. So let's try this. You see here now, this is a map of later in a geographic information system, QGIS. You know this already, open source software environment. So you see here we have many basins in Central Asia, in the zones of runoff formation. Up here, this is the upstream Kyrgyz Republic, the Tian Shan Mountains, the Isaralai Mountains here, and the Pamir Mountains, Hindu Kush Mountains. You see a lot of very vital mountain ranges where water is generated, runoff is generated, for the water then to run off from these mountain ranges into the downstream where it's consumed in vast agricultural bases. Okay, these are these green patches. So now, if we want to understand, let's say, one basin and we want to model climate impact, the topic of this chapter, then we need to set up a model. And of course, the topic of this chapter is the basin, the focus basin is the Serapshan River Basin, which you see here. This majestic, very long basin, which is like a pipe, carved into the Isaralai mountain range, which is a vital source of water supply for Samarkand, Navoy, Bukhara oasis. If you want to make a model, and as we discuss of Serapshan River Basin, and as we discuss in this is again Serapshan River Basin, and as we discuss in this chapter 12, we have one gauge, one observation, one monitoring point at which we have data available, which we would like to reproduce then with the hydrological model. For this gauge, for this point, we would like to make a hydrological model in the upstream. So it's pretty straightforward what we would have to do. We would have to basically make a gauge, an observation point. So I'm going here, this is RS Minerve. You see here the window into RS Minerve. So what I'm doing basically is I'm just making a junction, which is a convenient element, which allows us to bring together different source types and flow types. So I'm putting a junction here. And I'm saying this is my gauge. So for example, which is interesting, this point here. Okay, and that's my gauge. And here I have an observation. This faucet type of icon is an icon which represents a source term, which represents an observation, so to say. So we can say here, this is my, for example, my observation, discharge observation. And now I can put in an element of comparison. It's called the comparator. Okay. So what is happening here? The gauge. This is my hydrological. This is my simulation. Okay. I connect to this my model, and here I'm using a model in the upstream, one HPV model. That's just my hydrological model, which produces discharge, and then which feeds in the discharge from upstream into the gauge. Okay, and so I say here, so the HPV model provides the water, the flow from Q upstream to Q tot. This is right now not very important, but that's what I'm doing. I'm basically connecting this with that. I mean, don't get carried away. This is not about RS Minerve. I showed you RS Minerve, but it's just to give you an idea of how to think a basin conceptual map. Okay, so this is my gauge then. Okay, in the downstream. So here is my runoff generating mechanism, my hydrological model, my gauge in the downstream, and here I connect the simulation, downstream flow to the simulation, and here I connect the flow to the reference, okay, because this is my observation. Now, when this would be running, it would be a functional model. I could then just double click here and get a comparison, the observation as compared to the simulation. But that's basically how we think of the simple most representation of a very complex catchment like Sarafshan, for which in our case we only have one gauge. Okay, there's one gauge here, which is Sarafshan Rabat-Hoxha, exactly the point where water comes from the upstream and flows into the upstream Tajikistan and flows into downstream Uzbekistan. Voila. Now, that's how we can think of this basing and the conceptual representation of our modeling approach in the most simple manner. And now you say, well, this is very boring, this is just one, observation point, a gauge point, one discharge observation, one comparator, and, an upstream runoff generating mechanism here represented by this HPV node. It's pretty boring, So what I want to show you is that how you can also think of or use such an approach to represent, conceptualize much more complex systems, hydrological systems, like, for example, the Chirchik River Basin. Now, this is another beast. This is much more complex, and you see here. This is Tashkent oasis, and Tashkent here, down here, it's located here, and this is the Chirchik River Basin. Up here is the zone of runoff formation. By the way, you can read all up on this basin in section 2, and then in the chapter 2, excuse me, and in section 2, which is a very detailed description of Chirchik River Basin. And you see here it's not just one gauge, the outflow of quite a simple catchment, but here we have different types of rivers flowing together, forming the majestic Chirchik River. Okay, so let's go around in clockwise direction. Let's start with this gauge with the Chirchik 16262 Chirchik River Gasal Cave, which is below the big Charok Dam. You see here a picture. There's a big reservoir, very important for Central Asia, not just for hydropower production, but also for regulating and for ensuring that agriculture has enough water in the downstream. So this is this reservoir, which is located here in the upstream. Below the reservoir, we have gauge with data 16262, that's Gasal Kent. And then also below the reservoir, we have a tributary. A right tributary, which is not bad, but it's a relevant river, Ugam River. And here we have the Kochi Kent gauging station at on Ugam River. And then we also, very close, we have a gauge, which is a sort of, which is like an artificial gauge, which takes together all the inflows. So that's the 6924, which is sort of all the total inflows summed up in that one artificial gauge, which is the 16924 gauge here. And then we have a gauge at Navarisoy River, Sichak. Okay, we have the very important Skem River, Mulala gauge. And we have, of course, the Chatkal River Basin, we have Hudai Dot gauge. And then there is also another, so to speak, gauge, which is not a real gauge anymore after the construction of the Charwak Reservoir, which was a real gauge but drowned, and now it's just an artificial gauge for the Koksu River, which is sandwiched into Skem and Chatkal River Basin, in between those big mountain river basins. It's a smaller tributary, nevertheless contributing somewhat to the inflow to Zhumabaev reservoir. So if you now ask yourself, so this is very complex, and how do I make a representation of that system? Well, I can think of this system in a very similar manner as I did before, with a very simple representation of this is one river, and I can just put different types of tributaries like this together. Okay, so what I'm showing you here now, first conceptual model of the Chirchiq River basin, and what you see here is basically a network representation of that basin, the situation of how individual tributaries flow into the main river and contribute to discharge. And remember what I started with was Gasal-Kent gauge, which is below the dam, it's down here. And then, the first right tributary below the dam is Ugam. Remember? So we have this Ugam confluence, and then the Ugam gauge. So this is where we have data, the measured discharge data available, and we compare that as we did that before. Simulated flow with the real flow and this gauge, and in the back, in your back upstream, we have that runoff generating mechanism, that the hydrological model here stylized by this HBV element. Okay, this can be much more complex, of course, in the real model then, but it's just here in this representation. It's just something which is an indication that that is runoff generating. But then we have the Zhumabaev reservoir. Now, mind you, I did not now represent this as a reservoir. I could also have taken, this reservoir node over here, but I don't, because I'm not interested in studying operating rules right now with in my climate impact study, because I will never know the real operating rules. Rather, I'm interested in studying climate impact on water availability, and I can then compare long-term norm water availability at the baseline period in future periods, for example, Gasal-Kent, without having to worry about the operating rules in the reservoir. So that's why I'm not explicitly taking this into account. If you have a different modeling goal, for example, optimize zero irrigation water supply and hydropower production at the same time, then you certainly also want to take into account the Zhumabaev reservoir and represent it as a proper infrastructure element. Okay, so now, after having explained this, I'm just representing my Zhumabaev reservoir as a confluence of many inflows. Okay, so you see here I have inflow of now Bali soil river, again with one gauge, one comparator, and gauge data coming. Then Skem Mulala gauge, this is Skem river contribution. Here I have my virtual gauge from Koksu, okay, check connected to Koksu discharge regime. And then I have a Budai dot, which is the Chatkal River, enables us to represent the whole complex Chirchiq River basin in a very abstract, conceptualized network representation. And that's the important thinking you want to put at the beginning of every modeling exercise. Ask yourself, what is the goal of your modeling? How do you then translate that into interconnected functional elements that you can subsequently refine as required by your particular modeling study? And this is, of course, not a functional model now, but because this RS Minerve is such a fantastic tool that enables us to connect nodes, relevant nodes, important nodes together as we want them in a network type fashion, we can actually really think of, do this exercise, and it will help us think about simple or more complex representation about the world system. So I hope you liked my little introduction. Yeah, it was helpful. And with that, I will say bye-bye.